Here we're going to look at examples where you have to draw on everything you have learned about trigonometry in order to solve problems. So you have to know when to apply the primary trig ratios, the cosine law, and the sine law. So let's look at the first example here. It says one car leaves Kingston and travels east at 80 kilometers per hour. At the same time, a second car travels in a direction 30 degrees south of east of Kingston at 90 kilometers per hour. How far apart are the cars after 3 hours? So let's start by looking at the direction the cars are traveling at. We can draw a compass to help us. North is going to be up here, and then east is going to be to the right, and then south down, and then west to the left. So one car, if Kingston is right here, is leaving Kingston and is traveling east. So it's going in this direction, and it's traveling 80 kilometers per hour. So this is going in this direction. The other car, it's leaving Kingston, but it's traveling in a direction 30 degrees that is south of the east direction. So if this is the east direction, you're going to rotate 30 degrees towards the south. So another car is traveling in this direction like so. Okay, so these are the two directions. Here's one. Here's the other, and this is 30 degrees. So south of east means you start going east and then rotate 30 degrees towards south. Okay, now how far did these cars travel in 3 hours? If one traveled 80 kilometers each hour for 3 hours, it would have traveled 240 kilometers in total. And how did we get that? We take 80 times 3 to give us 240, right? 80 kilometers in the first hour, 80 in the second, 80 in the third. So you can just write that as 80 times 3. Okay. This is the speed. This is the time. So if you take speed multiplied by time, you get distance. So here it's 240 kilometers. The other car is traveling 90 kilometers per hour. So how far did it get after 3 hours? So again, 90 kilometers in the first hour, 90 in the second, 90 in the third. 90 times 3 gives us 270. So the second car traveled a total of 270 kilometers and traveled farther because it was going faster at 90 kilometers per hour. So again, speed times time equals distance. So this is 270 kilometers. And we need to find out how far apart are these cars here. So I'm going to first label the triangle here. Letters A, B, and C. Okay. And these would be the angles, and now the sides. The 270 kilometer side would be side B because it's across from angle B. The 240 kilometer side is going to be side C because it's across from angle C, and the side that we're looking for is side A. I have two sides and the contained angle. I can use the cosine law then to find side A. So the cosine law is the modified Pythagorean theorem, so I can start by writing A squared is equal to B squared plus C squared minus 2bc cos of angle A. So the outside letters have to be the same, and then you have the other two letters in the triangle in the middle. Okay, the order of these letters doesn't matter, but if you're looking for side A, you have to have cos of angle A here on the other side. We have all the information, now it's just a matter of subbing in the values. So for side B, I'll sub in 270, for side C, 240. And then for angle A, it's going to be 30. And then I can enter this all in one step in the calculator. And just bear with me for 1 second. And we get this value of 18,263.11. Now remember, this is A squared. So to find A, you would have to take the square root of this value, just like you would if you were using the Pythagorean theorem. And the answer becomes 135.14. So writing the therefore statement, therefore after 3 hours, the cars are 135.14 kilometers apart. Okay, let's look at another example here. It says, the posts of a hockey goal are 2 meters apart. A player tries to score a goal by shooting the puck along the ice from a point 4.8 meters from one post and 6.7 meters from the other post. Within what angle must the player shoot? So I'm going to draw, looking down, this is like the net, and this is the goal posts. And then you have a player somewhere over here. And the distance from the player to one post is 4.8 meters. And then from the player to the other post over here, that's going to be 6.7 meters. And we know that the hockey goal is 2 meters, and obviously this is not to scale, but it's a diagram that's going to help us figure out within what angle must the player shoot. So the player is over here and he has to shoot within this angle here. So I'm going to label this triangle, and I'll label it A, B, and C for simplicity. Okay, I'm going to label the sides. So across from angle C, I have side C of 2 meters, and across from angle B, I have side B of 4.8 meters, and across from angle A, I have side A, which is 6.7 meters. Since I have all 3 sides and I'm looking for an angle, I can use the cosine law to solve for this angle. Writing the cosine law, looking for angle C, I'm going to start by writing cos of angle C is equal to A squared plus B squared minus C squared all over 2AB. Again, the outside letters have to be the same. So if I'm looking for angle C, I should be subtracting C squared. The inside letters can be in any order, okay? And it's the 2 remaining letters. Now subbing in the values here. So I have 6.7 for side A and 4.8 for side B and 2 for side C. And I'm going to figure out the numerator separately from the denominator at this stage. So in the numerator, I get 63.93. In the denominator, I get 64.32. And if I want to find angle C, when I know the ratio, this is the ratio, I just take the inverse cos of this ratio. Giving me an answer of 6.31 degrees. And then writing a therefore statement, since it's a word problem, we write therefore the player must shoot within an angle of 6.31 degrees. Okay, and one last example here. A UFO appears to be flying overhead of the town of Roswell between two tracking stations. The angle of elevation from one station is 42 degrees and from the second station is 52 degrees. If the stations are 1,500 meters apart, what is the altitude of the UFO? So let's start with a diagram. We have these tracking stations on the ground with the UFO up above. So I'll call one tracking station A, the other B. And then the UFO is somewhere above here, and I'll label it C. And I know it's not halfway in between because then the angles will be the same. And it says that the angle of elevation from one station is 42 and from the other is 52. The angles of elevation are with respect to the horizontal. So here's the horizontal and a line of sight to the UFO. And so this is 42. And here's another line of sight and a horizontal. So this angle here is going to be 52. And the distance between the two tracking stations is 1,500 meters. We're asked to find the altitude of the UFO, and altitude means height. How high above the ground is the UFO? And this is what we're looking for. So the height is part of both of these right angle triangles. If we were to use either one, we would need to know an angle on the side. In both of these, all we know are angles. So we need to find a side. The way we're going to figure out the side is to use this non-right angle triangle, triangle ABC, because we have two angles and a side. We can use the sine law to either determine side AC or side BC. So let's start there, and I'm going to just redraw the non-right angle triangle here. And relabel it. And I'm going to label the sides according to the letters that I used for the angles. So the 1,500 meter side, because it's across from angle C, is going to be labeled side C. And this side, which is across from angle B, will be labeled with lowercase b. And this side will be side A. And I can use the sine law to find either one of those sides. I'm going to find side B, but you can also use it to find side A if you wish. It really doesn't matter for this question. So writing the sine law, I have A over sine of angle A is equal to B over sine of angle B, which is equal to C over sine of angle C. And I'm only going to use two of these three ratios. One of them is going to contain side B that I'm looking for. The other one has to contain an angle and a side across from it, since I know side C, and I can find angle C because I know that all the angles inside the triangle add up to 180. I'm going to use that ratio. And here on the side, I will calculate angle C by subtracting 42 and 52 from 180, and that will give me 86 degrees. Subbing in the values now here in the sine law, I have B over sine of 52, which will equal to 1,500 over sine of 86. Cross multiplying, and we get B sine of 86 is equal to 1,500 sine of 52. And then dividing both sides by sine of 86 to get B by itself. The answer that we would get for side B is going to be 1,184.90. Okay, so now that I know this side here is 1,184.90 meters, I can use this right angle triangle here on the left to find the altitude of the UFO. I'm going to redraw the triangle. down here at the bottom where I'm doing my calculations. So in relation to this 42-degree angle, the side that I'm looking for is the opposite side. And the side that I just found is the hypotenuse. It's across from the 90. And the primary trig ratio that I'm going to be using is going to be sine. Subbing in the values, I'm going to sub in x, the opposite side that I'm looking for, and 1184.90 for the hypotenuse, and then cross multiplying, I would have to multiply 1184.90 by sine of 42 to give me an answer of 792.85. So therefore, the UFO is at an altitude of 792.85. Whoops, I transposed my numbers. 792.85 meters.